Hello students, in the series of water resource engineering, I am going to continue mode of failure of the gravity dam. So, a gravity dam may fail in the following four ways: overturning, sliding, compression, and tension. So let's see. First one is overturning. If the resultant of all the forces on a dam if any section cut its base of the dam downstream of the toe, as you can see in the figure. Downstream of the toe, the dam shall rotate and overturn about the toe. On the other hand, if the resultant cut the base within the body of the dam, there is no overturning. As you can see in the figure, there are two type of forces acting on the gravity dam. First, horizontal forces and vertical forces, and the resultant of both is sigma r. Right? If the resultant force cuts the base of the gravity dam, or within the body of the dam, it cannot be rotated, cannot be overturned about the toe. If the resultant force does not cut the base of the gravity dam or lies outside of the gravity dam, it will be overturned about the toe. So, for stability requirement, the dam should be safe against overturning, and the factor of safety against overturning is the ratio of restoring moment to the overturning moment. As you can see in the figure, where sigma mr is restoring moment and sigma m is overturning moment, and the ratio of this should be greater than 1.5, should be greater than equal to 1.5. Next, sliding. Next, sliding. Next, sliding. Let's check. A dam fell in sliding at its base or at any other level if the horizontal force causing sliding are more than that resisting developed at that level. The resistance against the sliding may be two types. First one, due to friction alone, and second, friction and shear strength of the joint. Friction and shear strength of the joint. The factor of safety against sliding, in which shear strength does not taken into account. The factor of safety against sliding, Fs is equal to mu sigma v upon sigma s, where mu is the coefficient of friction, and the value of this coefficient of friction varies from 0.65 to 0.75. And sigma v is the net vertical forces, and sigma h is the summation of horizontal forces causing sliding. And factor of safety against sliding, in which shear strength taken into account, FOS is equal to mu sigma v plus b into q upon sigma s, where b is the width of the joint, and q is the average cohesion or shear strength of the joint, and sigma v is the net vertical forces, and sigma s is the summation of the horizontal forces causing sliding.